All right, so I wanted to make a quick video. Well, it might not be so quick. We'll see how it goes. About the Algebra 1 Mod 2 packet that I have given you. The first page is all asking the question, determine if y is a function of x. Sorry, that just simply means, is the graph a function? If you're given a picture, you can do what's called a vertical line test. As long as that vertical line only intersects one point on the graph, it is a function. So number 1 is yes, this is a function. If I look at number 2, and I draw a vertical line, here it hits here, but this is an open circle. That does not count, right? Here it hits once, but an open circle. Here it hits once. Here it hits once. Okay, so it hits once in all the, like if you look here, like the open circle does not count. It's not equal to there, but it is equal to in the filled in circle. So in this graph, the vertical line shows that this is a function. This is a yes. All right, then let's look at number 3 is probably on the next slide because of the way the picture is. So we're just going to look at number 4. We're going to determine if this is a function. Well, look at this graph. If I draw a vertical line here, every single point on that line hits. That is a hard no. This is not a function. I'm looking at number 5. Well, we have open and closed circles again. So if I draw, right, we just hit there once, we just hit there once, and then, oops, I missed it, we hit there just one time. So yes, this is a function. All right, number 3, if I draw my vertical line, here it's good, here it's good. If I draw it here, it is not good. It hits twice, so this is not a function. Number 6, again, we have open and closed circles. So, number 6 is a little different. Look, it says the graph of the function is shown below. Is -2 in the range value? Remember, range is y. Well, we look where y is -2. That's all along this here. Is there any point of the graph that's in that function? No, there's not. So no. -2 is not in there. All right, that's one page down. All right, 7 and 8 are very similar, but what you're looking for is if I draw a vertical line, how many times am I only going to intersect that closed dot once? And the answer is yes. All right, when we look at number 8. Why is he not reading this? Oh my goodness, I'm so sorry. Please forget. All right, it says this is 0.5 in the range. Well, if this is 1 and this is 0.5, or negative 0.5, this is positive 0.5, and that's positive 1. No, there's nothing here, so no. 0.5 is not in the range. Is -2 in the range for number 8? Well, -2 is right here. So yes, it is. This is where y equals -2. All right, number 9, it says a whole bunch of stuff, okay? They give us this equation. All right, they tell us that the pizza is a charge for pizza and then has a delivery fee that's added on. Well, what is the delivery fee? That is our y-intercept. So the delivery fee would be $2. Okay? In number 10, here's our equation. They say the cost in dollars. Again, the restaurant charges a fee for the pizza and charges for the pizza and adds a delivery fee. So C is the total cost in dollars, and then I have to buy a certain number of pizzas. How much does each pizza cost? Well, each. Every time you see the word each or per, I want you to think about rate. So that would be my slope. So $10. Each pizza is $10 plus a $6 delivery fee. All right. Number 11. Again, here's my equation. Well, now we know the slope is the cost of the pizza, and the fee at the end, or the y-intercept, is my delivery fee. How much is the delivery fee? It's $8. Number 12, here's my equation. Well, we know 15 is the cost of the pizza, and the $13 is the delivery fee. How much does each pizza cost? $15. It's very easy once you understand when you see an equation like that, what the things represent. So slope is always per or each, it's a rate. All right, number 13. What I want you to, first off, let's take a second and look here. This number is supposed to be 41. I don't know who made this, but this is incorrect. That has to be number 41 because this is a function. Okay, so what it's asking for 13 is to write the linear equation. Linear equation is y equals mx plus b. All right, these are a whole list of ordered pairs, 2 comma 6, 5 comma 21. Don't use that 14. Let's just start with the first two ordered pairs, 2 comma 6 and 5 comma 21. You have the formula sheet. You know how to find slope. Slope is when I subtract my y over subtracting my x's, and that gives me 15 over 3, which is 5. All right, so I know that my m equals 5. At this point, we pick a point, and we're going to use point slope. Again, that is on your formula sheet. Y minus y1, which is my 6 here, equals my slope times x minus x1. Distribute and add 6. You're literally just solving for y. Once I add 6 here, I get y equals 5x minus 6. That is my linear equation. All right, here again with number 14, it's the same thing. That's a list of ordered pairs. I did not notice an error in this one, so again, we're just going to pick these first 2 points. All right, so I have 2 comma 11 and 6 comma 23. 23 minus 11 over 6 minus 2 is 12 over 4, which is 3. So my slope is 3. And you pick any point you want. I'm just going to pick this one because it's right there. Y minus 11 equals 3 parentheses x minus 2. Distribute my slope and add 11. And I get y equals 3x plus 5. That is my equation of the line. All right, 15 and 16 are exactly the same, but what I want you to do is pause the video and see if you can do it on your own, because there's no point in you just copying down what I'm doing. I need you to be able to do it too, okay? So here's 15 and 16. 17, don't worry about that. But I want you to pause the video and see if you have the right equation. All right, take a second and check it out. So I have the answer for number 15 is right here. Y equals 1/2 x plus 3. Sorry, that's the 3. I did find the slope was 1/2. I used my first 2 ordered pairs in the table. For number 16, again, I used my first 2 ordered pairs in the table. I got a slope of -2. And then I plug that into the point slope formula, and I get y equals -2x plus 4. That is the equation. All right, number 17, it says Jeffrey sells hamburgers. The amount he charged for hamburgers are H, based on the cost of a plain hamburger plus an additional charge for each topping. So as shown in the equation, what does the number 5 represent? So a plain hamburger plus additional charge for each. Each is the rate. So that's my slope. So that means this is my slope. So what does the 5 represent? Well, it represents the y-intercept, but it also represents the cost of each hamburger. Without them, obviously. Oops, I went the wrong way. There you go. Okay, number 18, here we go. Well, we just talked about the slope, the rate, right? Each topping, that's going to be this guy right here. So what does the 0.8 represent? Well, that's the cost of topping. Number 19, again, we're still stuck on this hamburger store, okay? So here's the equation. The hamburgers are 60 cents for the toppings plus $5 for the burger, right? So the T represents, it's literally right here. It tells you T is topping. Topping. Kind of looks like tapping. Oh boy. Accountability. All right, cool. Next, number 20. What does the number H represent in the equation? Well, every restaurant sells hamburgers. So this is the cost of the burger plus the topping. H is the total cost of the burger with the topping. It's like, usually we see Y equals MX plus B, but in this case, they changed it to H and T. H is the total cost of a hamburger with the topping. Hallelujah. Oh, sorry. Oh, Lord, look at this lovely thing. Okay, number 21 is super easy. This is a graph of a linear equation, right? It's a straight line. Write the equation represented in the graph above. Okay, so y equals mx plus b. What are we looking for? Well, we're looking for m and b. Those are numbers. This is the y-intercept. That's easy to see. Where does it cross the y-axis? Right there. What's that value? 2. So b equals 2. If I have 2 points on a graph, I can do the rise over the run, or I can use the slope formula. Whatever you want to do. 1, 2, 3, 4 up. 4 is my rise, but my run is to the left, which is negative. So that means the slope is negative 4. If you wanted to use the ordered pairs and use the slope formula, I'm going to write that down quick. We'll just say, okay, this ordered pair is 0, 2. I'm going to change colors here just to do the slope formula. So 0, 2, and this point is 1, negative 2. All right, negative 2 minus 2 over 1 minus 0 is negative 4 over 1, which is negative 4. So it turns out either way you go about it, it works out. Just be real careful if you're running this way, that's negative. All these numbers are negative, right? So if you had to go down, you know that was negative, and over would be positive. Okay, so let's put the information together. We have what we need. So y equals negative 4x plus 2. Fabuloso. All right, number 22, the graph is shown below. It's going to be exactly the same thing. Okay, so we are going to, wow, try to see where it crosses the x-axis. Or not. Let's just not assume that it crosses right there perfectly. Let's use the 2 points. So that is 1, 6. And this is negative 4, negative 2. Okay, if you can't really clearly see that that point is this on the y-axis, it's probably better to just find the slope, use point slope, and write the equation out. So the slope is negative 2 minus 6 over negative 4 minus 1, gives me negative 8 over negative 7. It's positive 8 over 5. Not the nicest slope. I'm going to use that slope and that point, this one right here, so y minus 6 equals 8 over 5, parenthesis x minus 1. And distribute this and get 8, this x minus 8, this y minus 6. And then I'm going to get my fancy little calculator out, and I'm going to add 6 to both sides. And I'm going to turn that into a fraction. So we have y equals 8 over 5x plus 22 over 5. That's what you get when you add, because on the side, like if I wasn't using the calculator, how would I add 6? Well, they have to have a common denominator. So if I need this to be a 5 down here, that means I multiply this times 5, that gives me 30. And negative 8 plus 30 is positive 22. You can do it without a calculator, but it takes a little bit more time. So you have a calculator, just make sure you know how to convert it to a fraction, either second PRB or, oh, and that would be a mixed number, so then you'd have to go second ABC to get it to be an improper fraction. I'm not sure how particular they are on these tests. Okay, so number 23. Do you see the y-intercepts? Like, I don't know, is that 5? I'm not really sure. I have to find points, exact points. So what I'm looking for is this is really a really lousy graph is what I'm looking at because it increments in 2s and I don't see where it crosses exactly anywhere, really. So we can say that that point is 0, 5. And then I can say this point is negative 5, 0. Okay, well, I'll say that. So 0 minus 5 over negative 5 minus 0 is negative 5 over negative 5, which is positive 1. That's my slope, positive 1. This is my y-intercept. I don't even need to write an equation. Y equals x plus 5, or 1x plus 5. All right, number 24, more graphs. We love the graphs. They're such a good time. All right, so what we can do, again, I kind of see the y-intercept is right here. It's definitely pretty obvious. V equals 0. I can count the rise and the run. I'm going to count up 1, 2, 3, 4 is my rise, and my run is 1, 2. So my slope is 4 over 2, which is 2. So when I put that together, I get y equals 2x. You could write plus 0. You don't have to. That looks good enough to me. Oh, these are my least favorite things on the planet. What you need to do is pray. No. So a scatter plot, a line of best fit, what you want to do is you want to try, and I'm going to try to use this tool, get this out of here a little bit. I'm going to try to use a line tool to kind of get in the middle of that data. This is where I'm just like, okay, so then it's like 3 dots above the line, 3 dots below the line, and some of them are kind of touching. So, but I feel like this one's so much below, like maybe I should drag this down a little bit. This is my least favorite topic in math, I will be honest. All right, determine the equation that best describes a line of best fit. So what you're doing is now you're looking for either points that are on the line or places that actually cross. So if I get my little pen tool here, I see that looks like a point which is 22, 500. And another exact place to me, it's hard because of the lighting in here. I don't know, I guess right here. That looks good enough to me, 10, 100. All right, so 100 minus 500 over 10 minus 22 gives me negative 400 over negative 12. And if I get my fancy little device out, I actually didn't do this one on the paper, negative 400 divided by negative 4. Oh boy. 33 and a third. Yeah, 100 over 3. That's a lovely slope. All right, so we're 33.3 repeating. I mean, I feel like that you can try your very best. Let's try to write the equation of line. I'm going to use this point this time. So y minus 100 equals 100 over 3 times x minus 10. All right, so when I times that by negative 10, how does that work out? It's 1,000 over 3. And I'm going to add 100 to that. becomes negative 700 over 3. What am I missing? It just doesn't seem very right, does it? That my y-intercept is negative. But again, scatter plots, not my favorite thing. Show as much work as humanly possible. Of course, we have more scatter plots, which is so fun. All right, so we're going to do the same thing. I'm going to try to draw a line of best fit. My very best, as best you can. It kind of separates the data. This one's even worse because it doesn't even have grid lines. So now we've really got to like kind of like line up my points. Like I want something on the line or close to the line. So if I look here, two, that's not the best. And then I'm like, okay, what about four? This seems super linear here. No, looks like it's 8. So if I go up, hopefully that's it, right? Over here. That's about almost 9. Oh man. See what I mean? I don't know if you guys feel my pain, but I don't like it. Alright, I'm just like estimating here. 7 over 6. What a lovely slope. Alright, so we're going to use one of these points. I'll use this one. Alright, we distribute. Negative 2 times 7 over 6 is negative 14 over 6. And I'm going to add 2 to that. And y equals 7 over 6x minus 2, 6, which is 1/3. Let me just double check my calculator. If I take negative 14, 6 plus 2, get to negative 1/3. Again, it doesn't really look like the way this graph is that my y-intercept is negative, but I mean, it's close enough. Close enough. Oh, fun! More scatter plots. All right, so let's do my frowny face. I do not like the scatter plot. I just don't even. I just don't know. I'm gonna try. Because like, look at these numbers. Now these are in. Starting at 6 day going up, and then this one starts at 1. It's a huge gap between 2. Like, it's so weird. I guess it's in tons, but anyway. All right, line tool. I'm gonna try. Okay. I mean, what do you guys think? When you look at that line, does it look like it splits the data in half? No, it's just so ridiculous. Okay, I'm gonna stop complaining. Okay, so when I look at this 80, it goes up here. And I look over here, it's a little bit past 1. So, oh boy, this would be 2.5. So let's just say 2.2. So 80 comma 2.2. Okay. And then I'm like, where else are we touching a point? I go up 120. Oh gosh. I'm gonna go over here. I have to try to figure out what that is. Well, half of it will be like here. That would be like 3.5. So 3.2 again. All right, 3.2 minus 2.2 over 120 minus 80. 2.2 minus 2.2 is just 1. Right. Now I'm having a brain fart because these numbers are just not so good. Yeah, and then 120 minus 80 is 40. All right, 140 if that's my slope. What a great slope. I'm going to use this point because I already pretended it was there. Y minus 2.2 equals 1/40 times x minus 80. distribute, y minus 2.2 equals 1/40th x. 1/40th times negative 80, I think it's 20, negative 20. Oh, let's just type in negative 20. Oh, it's negative 2. Please forgive me, negative 2. Okay, so then I add 2.2 to it, and I have y equals 1/40x plus 0.6. Oh, it's the first time I didn't get a negative slope, which, I mean, still, look at this line. It's in between 1 and 2. Anyway, okay. It's fine, guys. Don't judge. It's fine. That's fine. I mean, what are you going to do with lines of best fit? I tried my best. Well, thank God we're moving on from that. Let's get into something a little more fun, something we can do. Remember, median is the middle, mean is the average. The first thing you do when you're given a set of data is to rewrite them in numeric order, from least to greatest. So 73, 80, 82, 82, 88, 93, 95, 96, 98, and 99. Always do a quick check to count your numbers and make sure that they are. I usually slash them out, but I'm trying to save time. I feel like I'm already going too far. So originally we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have 10 numbers. Cool beans. The median is literally the number in the middle. So if I slash away, starting with the lowest and the highest, then I keep going, and keep going, until I squeeze in the middle. So now I have 1, 2, 3, 4 slashes on either side. I have 2 in the middle. That means the median is in between those. So what you want to do for the median is add the numbers together and divide by 2. So that's going to give us 88.6. For the mean, you're going to add all the numbers and divide by how many there are. So for the mean for this set of data, I got 90.5. All right, the mean, this is the mean, and this is the median. Number 29, now we're looking for the median and the mean again. We rewrite the numbers, least to greatest. All right, so 32, 45, 48, 49, 53, 66, 60, 63, 68, and 72. Cool, 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 cool. Again, just quick check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool, cool, cool. Let's find the mean. So we add up all the numbers and then divide by 10, and you should get 54.6. And the median, we're going to find in just a second. Since they're an even set, we know they're going to be in between. So we're going to have 1, 2, 3, 4. 1, 2, 3, 4. It's just like the one above it. I have 10 numbers. Add those two numbers up. 53, 55, that's 109. Divide by 2. That is 54.5. Both of those numbers are very close to each other, so that's kind of a good representation of the average. All right, 30 says a box and whisker plots, okay? Some of you hate box and whisker plots, and some of you don't. I'm not sure. Just remember, the median, which we already know how to find, it's the middle, that's your second quartile. So you're going to need your minimum, maximum, you're going to need your first quartile, second quartile, and third quartile. The quartiles are the bars of your box. The mean and the max are the smallest and highest numbers. But let's reorder these numbers so they're least to greatest. So 76, 79, 83, 84, 88, 88, 92, 95, 95, 96. Let's do a quick count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, there's 10, so we know, well, first off, this is the min. That's my whisker. This is the max. That's my other whisker on the end. Okay, we got to find the median, the middle. So we'll go in 4, 1, 2, 3, 4. So these two numbers in the middle. So it's like weird if they're the same number and you add them and divide by 2. It's going to split the data right here. This is my second Q, which is 88. Let's go on the numbers here. So it's 76, 88, and 96. Okay, the first quartile is like from here to here, it's the median of those numbers. So you're looking for the middle again. That's right here, 83. The third quartile is the median from the upper half. So from here to here, right? Slash away, you get to the one in the middle. Some teachers want you to write a whole number line. I don't know about you guys, but I like to get to it. So I know the second quartile is 88. And I know the first quartile is 83. I know the third quartile is 95. That's my box. First quartile, second quartile, third quartile. Then my whiskers, 76. 96. I've just constructed a box of whisker plot. It didn't say to put it on the underline, so it's not a fact. So you are too. All right, I want you to do kind of the same thing we did with the other setup. When we're writing equations with lines of data. Here for number 31, I want you to pause the video, and I want you to make a box and whisker plot. And then come back and see if it looks like mine. All right, check out your box and whiskers. See if our numbers match up. And if you guys used a number line, that's fine. I mean, I'm more lazy. Another name they use for box and whisker plot is called a 5-number summary. If you notice that there's 5 important numbers on there, the minimum, the maximum, the first quartile, the second quartile, and the third quartile. Once you reorder them least to greatest, the min and max are super easy to see, so it should be the first things you identify. Then you must find the second quartile first, which is the median. If the median splits the data, like in half, and then over here the median of that first half is the first quartile, the median of the upper half is the third quartile. If the median just so happens to be a number here, then you don't use that to find your first quartile or your second quartile. You literally go from here and there, okay? If that happens. But if you have an even set, you'll split it. If you have an odd set of numbers, it will be one number in the middle, and then you'll have to like not include that. It's just food for thought. All right. Data analysis. Now we're going to look at some charts and stuff, okay? So first off, let's talk about what we got going on here. So if you are, there's different ways to go about this. Some people do set up a proportion, but I literally just look to see what percentage, because this data is based off of this scenario. They asked 200 students to select their favorite sport. So to find the percentage, here you take 200 and divide by 50, and that means that football is 25%. Okay, we're going to do 200 and divide by 75 for this one, and that gives me 37.5%. And once you divide, you multiply by 100 to get the percent. All right, so 20 out of 200, that's 10%. Hockey was 25 out of 200, which is 12.5%. Volleyball is the same thing. And track and field was 5. What was it? 5, 12.5. I mean, I'm not gonna tell you. You can see that this is up in between 0 and 1. So 5 divided by 200. Why am I doing that? Oh, it is. Oh my gosh, I have my fraction messed up. It is 5 divided by 200. Don't worry. But what was it? Garbage. And then whatever that result is, you multiply by 100. That's what gives you the percent. Okay, so that is 2.5%. Sorry, the how many students would go in the denominator, right? Here, they're asking 90 students. So they want to know how many more students of the next 90 will select basketball rather than football as their favorite sport. So if I took my 90 students times the basketball, 87.5%, which gives me 33.75, I believe. Let me just double check. This video is already glued to me. 33.75. And then we're going to subtract the guys that like football. 90 times 25%. So 90 times 25% is 22.5. This gives me 11.25 students. So about 11. About 11 more students. Because you can't have 0.25 of a student. All right, the next couple questions are pretty much all the same. But what I want you to do, all the charts are all the same. So the percentages stay the same. Or if you want to use the decimal, that's fine. You can use the decimal. But here you would say 50 divided by 200 is 0.25. This is 0.375. 0.1, 0.125, 0.125. 0.025. Okay? Now they're asking how many more students select hockey rather than track and field. So let's put hockey first, right? So we have 90 students times 0.125. It's 11.25. We're going to subtract our track and field students. This is 90 times 0.025. Which gives me 2.25 students. So when I subtract that, it gives me 9 students. Well, it's a whole number. I don't need to say, That's so great. Okay, so I'm just going to give you the answers for 34. If you want to do the practice, that's fine. Actually, you know what, pause the video and then I'll do it. All right, so you should have got about 13 because I got 12.5, but I'm going to round up. That's about 13 students would choose football rather than hockey. All right, one more graph like this. Again, pause the video, come back in a second. Now pay attention, this is 150 students, okay? All right, so over 35, you should have got about 41 students because it was 41.25. And round down, so it's about 41 students. All right, now we're going to talk a little bit about probability. Okay, so a number cube with sides labeled 1 through 6 is rolled twice. The sum of the numbers that end face up is calculated. Okay, what is the probability the sum of the numbers is 4? Well, let's say my first dice is a 3 and my second dice is a 1. Let's say my first dice is a 1 and my second dice is a 3. Let's say my first dice is a 2 and my second dice is a 2. Those are the only different combinations on a 6-sided die that could add to equal 4. So how many choices is that? That's 3. Out of total choices would be 36. Because each have 6 sides, so you multiply those together. And this reduces to 1/12. The probability is 1/12. Okay, number 7. Says a number cube labeled 1 through 6 is rolled twice, and the sum of the numbers is calculated. What is the probability the sum of the numbers is 12? Well, there's only one way you can get a 12 with the sum is if I roll a 6 and a 6. I can't switch the order. It's not going to change. You know what I mean? So that's only one choice out of 36. All right, number 38. A number cubed, 1 to 6, is rolled. What is the probability the sum is 8? Well, let's run through the 8s, okay? So 2 and 6, 6 and 2. 5 and 3, 3 and 5. And then 4 and 4. Okay, so that's 1, 2, 3, 4, 5 choices out of 36. Hope it's not reduced. All right, number 39, number cubed is rolled. What in the sum is calculated? What is the probability the sum is 13? And let's see. Well, the highest number on a six-sided cube is a 6, and 6 and 6 makes 12. There's no numbers, no way I can get a 13. So 0 out of 36. It's not possible. There's no chance. All right, we're almost finished here, guys. I apologize for this extended video. Okay, so what do we got going on here? We have a table. What I want you to think about tables is x and y. Time is usually x. Distance or sum is y. So we have ordered pairs. We have 0, 58. And we have 1, 143. Whenever it says write an equation, I want you to think y equals mx plus b. Okay, so what we're going to do is we're going to find the slope. 143 minus 58 over 1 minus 0 is 85 over 1, which is just 85. So that's kind of weird. It says here's 84 miles from home. Let me just double check my math. 143 minus 58. 85. Okay, okay. That's the rate in which he's driving. He's driving 85 miles an hour. I better slow down. Okay, and then I'm going to pick this point, right? This is my y-intercept. It's the value of y when x is 0. So if I put my slopes together, y equals 85x plus 58. There you go. That's the equation of the line. If we were just to check, let's just plug it in. Let's just check this. Let's check this one here. So if I take my thing, 85 times 3 plus 58, that gives me 313. I'm just checking my answer to make sure it's right, and it is right. So I did it. You did good job. All right, part B says, Hector also keeps track of the remaining gas. The equation shown below is used to find the gallons of gas remaining after the distance is driven in miles, okay? So what we're doing is we're plugging in. See this says B? See that says B? We're just going to plug in this value here. So 15 minus 1/20 times 100. That gives me 10. And we have, for this one, 15 minus 1/20 times 200. It's going to give me 5. This one is going to be 15 minus 1/20 times 300. That's going to be 0. You're going to be out of gas. That's not good. All right, here we go. So now what we need to do from that part B is we need to draw the graph of a line that's formed by the points. So I'm going to use these ordered pairs and graph my points, okay? So my ordered pairs, just to remind you, were 100, 10, 200, 5, and 300, 0. So, yeah, how is that happening here? So let's start with the first one. 100, 10, 200, 5, and 300, 0. I hate to put arrows on both ends, but because it's not. I'm just going to make a ray. It's fine. Explain why the slope of the line drawn in part C must be negative. Well, what do you guys think? Like, the longer you drive, what happens to the gas in the tank? It goes down. So because the farther you drive, the more gas you use. Done. Dun dun. All right, I don't know if you recognize this question. This is from one of your tests that you took. So what we're going to do is we're going to go through this, and this is going to be kind of interesting. Anyway, so first off, the median of the wrestlers, right? So what you want to do, always when trying to find the median, is list everything least to greatest. So start with the smallest, 122, then we have 140, then we have 152, then we have 160, we have 188, and 216. Okay. The median is the middle. So if we count, so like we just count like 1, 2, 1, 2. I have 2 in the middle. Okay, so what you're going to do is you're going to take those two numbers, add them together, and divide by 2. That gives me 156. That's the median. The mean is literally adding up all of those weights, which gives me a sum of 978, and dividing by how many there are. 1, 2, 3, 4, 5, 6. That gives me 163. All right, that was easy, easy, easy. Now it says that, oh my goodness, that went way too far. It says that 2 more wrestlers join the season. The additional wrestlers have no effect on the mean, so the mean's going to stay the same. So now I have 978 plus 1 wrestler plus another wrestler. I'm just putting in variables just to like kind of figure out what's going on here. But now I don't have 6 kids on the team. I now have 8. And it equals 163. What I'm looking for is just some more information just to give me an idea of like, how can I figure this out? Okay, because it's not magic. So what we'll do is we're going to just put solve for x and y. So here it's like, well, if I multiply both sides by 8, that gives me something. Hold on. 163 times 8. So is it 978 plus x plus y equals 130. Subtract 978. And you get x plus y has to equal 326. So that means the sum of the new wrestlers' weights together has to be 326. This guy plus that guy, total equals 326. All right, we know that and then it says that the median increased by 3. So if the median increased by 3, that means I need to come over here a little more. So I'm going to kind of, I guessed and checked. That's how I figured it out. Okay, so I know that I need to add a wrestler in here, and I need to add a wrestler in here. Okay, because I know the sum of their weights is 326. So I picked 2 numbers out of a hat. So I'm just going to get right to it. The 2 numbers I picked were 158 and 168. Because 158 plus 168 is 326. So that fits, okay? Then when I put those numbers in up here, let's just say I'm going to write them in. 158 and 168. Now when I'm trying to find the median, 1, 2, 3, 1, 2, 3. Now I have these 2 numbers are in the middle. So 158 plus 160 divided by 2, is that going to increase my median by 3 pounds? It gives me 159. So this is the new median. All right, honestly, that was my second trial. The first trial I was a little low, but then I figured it out, okay? So if you know the sum of the wrestlers, you can play around with numbers. Like, if you took this and divided by 2, that's not going to get you there because that's going to change. They're going to be like 326 divided by 2 is 163. So 163 is meaning I'm adding both wrestlers here. That's gonna make this go up too much, okay? So take your time, let me know if you have any questions, and good luck. Okay, bye.